Good morning everyone. I am Hsfg Bolts from Civil Engineering branch, and today I am going to teach you your Theory 2 paper which name is Structural Design 2. So in the last class we discussed various kinds of numericals and solved it according to the formula which is present in your code book. Okay. So today we will start with another bolting connection which name is Hsfg bolts. That means high strength friction grip bolts. So in the beginning of your class I told you that your bolts are majorly divided into two types. First one is your finished kind of bolt, another one is your unfinished kind of bolts, and another bolt is there which is high friction bolt, which is the superior in the bolts. Okay, so in the high tensile zone or in case of high load condition, this kind of bolts are provided. So first of all, you need to know what do we mean by Hsfg bolt, where it is utilized, what are the constituents of the Hsfg bolt. Okay. So now, first thing is your Hsfg, that means high strength friction grip bolts, are high strength structural bolts which have been tightened such as to induce predefined tension in the bolt shank. Due to the tension in the bolt, the interface between the piles, that means steel members in a joint, okay, cannot move relative to each other because of frictional resistance. Okay, because it is friction with grip provision so that it can easily resist any kind of tensile or shear also. So in case of ordinary structural bolt, that means your finished and unfinished bolt are made from mild steel, as you know that, with square or hexagonal head. But nowadays the hexagonal head bolted connection are more provided in the construction side. The most commonly used black bolts are of property class 4.6. You know that your M20, M15, it belongs to the property class 4.6, which is black bolts. Okay. They have high elongation and hence are more ductile. The holes for the bolts are provided with a clearance of about 1.5 to 2 mm more than the bolt diameter. Okay. For a given set of force, economic connection may not be achieved as the connection may demand a larger diameter or more number of such bolts. But in case of high strength frictional grip bolts are made from bars of the medium carbon steel. Okay, in case of ordinary bolt, it is made from mild steel, but the Hsfg bolt, these are made from medium carbon steel. Their high strength is achieved through quenching and tempering process or by alloying steel. They are less ductile than black bolts. The Hsfg bolt are available in two types of property class, or you can say the grade of the bolt of the Hsfg bolt are provided or available in two types. So first grade number is 8.8 and another grade number is 10.9. So this grade are designated from the IS code 3757, which is more popular in the construction sites. The next one is these are more suitable for the joints subjected to vibration. That means the area which belongs to the earthquake zone or the area where the chances of storms or chances of earthquake is more, this kind of area, while steel structure is constructed on that, at that time we need to provide Hsfg bolts instead of ordinary structural bolts. The knots and head of the bolts are kept sufficiently large to provide an adequate bearing area. Tensile strength of these bolts are much more higher than that of ordinary bolts. Hence, for a given force, lesser number of bolts may be required. So your HFC bolts are look like similar to the ordinary bolts, only here the 2 numbers of washer is provided to resist or to carry the tensile force coming on the joint section. So now comes to the design procedure of the Hsfg bolt. So I told you, in case of bolt section or in case of steel section, you need to calculate the strength capacity or the shear capacity of the bolts. So we already know about the strength of the normal bolt condition. So now comes to the shear capacity of the Hsfg bolts. So first of all is you have to calculate the nominal shear capacity of the bolt as per the IS 800-2007 code. So your nominal shear capacity is denoted as VNSF. Okay. So your VNSF equal to mu F NE KH capital F0, where your mu F equal to coefficient of friction. It is also known as slip factor of the Hsfg bolt. Then second one is your NE, which is number of effective interface offering frictional resistance to the slip, and the NE value is 1 or 2. 1 for the lap joint and also single cover butt joint. But in case of double cover butt joint, you have to take the NE value as 2. Then come to the KH. So KH is a factor for which 3 kinds of conditions are there. So first condition is if fasteners in clearance hole, then you can take the KH value as 1. If the fasteners are oversized and short slotted holes, and for long slotted holes loaded perpendicular to the slot, then you can take KH value as 0.85. Then if it is long slotted hole loaded with parallel to the slot, then you can take KH value as 0.7. According to the condition, you can take a number from this 3 value. Okay. The condition is already mentioned in your question. So you need to check out the values from the code book and then solve the problem. Then your capital F0 or FO equal to minimum bolt tension, or it is also known as proof load at installation, and it is calculated by ANAP into small f0. So you already known about the A and B. So this is, you can already calculate from the normal bolt connection, while the formula of A and B equal to 0.78 multiply with pi by 4 d square, where d is the diameter of the bolt. And the small f0 you can calculate, which means the proof stress. You can calculate the value as 0.70 into small fub, where small fub your ultimate strength in case of bolt section. Then calculate the VNSB. After that, we have to calculate the design shear capacity, or you can say design slip resistance of the Hsfg bolts by the formula, which is VSF. VSF is the symbolical representation of the design shear capacity of the Hsfg bolt, which equal to VNSF, which is nominal shear capacity of the bolt, divided by gamma mf. Here gamma mf is the partial safety factor or the slip resistance at the different kinds of load, or you can say normally the partial safety factor for the Hsfg bolts. So for the provision of the partial safety factor, there are two criteria. So for the slip resistance is designed at service load, then your gamma mf value is 1.1. And another thing is, if the slip resistance is designed at ultimate load, then your gamma mf value is 1.25. So according to the conditions of the slip resistance designation or design as per the ultimate load or service load, the gamma mf value is different. So you just put the gamma mf value according to the condition and VNSF value and divided it. Then you will get the value of design shear capacity of the Hsfg bolt. So today this much. We will discuss next of the thing in the next class. Thank you.